Hello and welcome to a new video on IGCSE mathematics. In this video, we shall be discussing quadratic applications in word problems. We will begin with distance, speed, time problems. A car completes a 200-kilometer journey with an average speed of x kilometers per hour. The car completes the return journey of 200 kilometers with an average speed of x plus 10 kilometers per hour. Show that the difference between the time taken for each of the two journeys is 2000 over x times x plus 10 hours. So in this case, all we have to do is first remember the rules for speed, time, and distance. You should know that distance is equal to speed multiplied by time. D stands for distance. V stands for speed. And T stands for time. So we can rearrange this equation to become time equals distance over speed. And this is what we're going to need to implement in this problem. So let's start over. And let's say as a beginning that time is equal to distance over speed. Now this problem requires the difference between two times, the time going forward and the time taken in the return journey. So since we're traveling between two specific points A and B, the distance moved from A to B must equal the distance moved back. So since it's a 200-kilometer journey, in both cases, the distance has to be 200. It is only the speed that differs from one journey to the other. So T1, in this case, the journey moving forward, is going to be the distance, which is 200, divided by the average speed, which is x. And T2 is going to be the same distance, 200, but this time divided by the new average speed, which is x plus 10. And our target is to find the difference between both. So we have to subtract one from the other. So 200 over x minus 200 over x plus 10. And this becomes a rational expression problem where we have fractions and we need to get a common denominator. So to get a common denominator, I multiply using the butterfly technique. If you're familiar with it, I just cross multiply these two together. So 200 times x plus 10. And then I insert the same sign that I have here. So I have a negative sign here. And then I cross multiply these two together. And I get 200x. And this is over the product of these two expressions. So x multiplied by x plus 10. Next, we need to distribute the 2 over the bracket. So 200 times x, this gives us 200x. Let me write that down. And then 200 multiplied by 10. So this gives us 2000. So plus 2000. And then minus 200x remains as it is. And this is all over x times x plus 10. So we are required to show that this is equivalent to 2000 over x times x plus 10. And this is very simple to show because 200x cancels negative 200x. So you're just left with 2000 over x times x plus 10. So that's it for question I. This is a show that, so we are already confident that our answer is correct because we got the same expression that they required in the problem. Let's move on to double I now. Find the difference between the time taken for each of the two journeys when x is equal to 80. So we don't need to do this over again because we already got an expression for the difference. The difference is 2000 over x times x plus 10. However, this difference is taken or is considered in hours. But they want the difference in minutes and seconds. So first of all, we need to plug the value of x that they gave us. So we get 2000 divided by, 80, which is this x here, multiplied by x plus 10, which gives us 90. You can use your calculator, 2000 divided by 80 multiplied by 90. Of course, you have to put 80 times 90 in a bracket so that the calculator interprets correctly. So you get 5 over 18 hours. So this is equal to 5 over 18 hours. But they want this in terms of minutes and seconds. So how would you do that? So first of all, let's try to convert it to minutes, and then we'll figure out the seconds later on. So how do you convert this to minutes? Simply by multiplying by 60. So let's multiply our answer by 60 here. And using your calculator, you get 50 over 3 minutes. So this is the same as 50 over 3 minutes. Now, how do we convert this to minutes and seconds? First of all, I would recommend that you do long division if you know how to do long division, because it's the easiest way out. So if not, I'll show you another way with the calculator, but I think long division is easier here. 50 divided by 3. So 5 divided by 3 is 1. 1 times 3 is 3. 5 minus 3 is 2. You bring down the 0. 20 divided by 3 would be 6. 6 times 3 would be 18. You subtract and you get 2. 2 divided by 3 is 2 over 3. So how does this help us? Because we know that we have 16 minutes. So this amount is equal to 16 minutes and 2 over 3 minutes. And we want to get rid of the 2 over 3 minutes. So we convert it to seconds by multiplying by 60. And that gives us 40 seconds. And this is our final answer, 16 minutes and 40 seconds. If you don't like long division, there is another way. It's slightly longer, but you can also use it. Our task is to convert 50 over 3 minutes into minutes and seconds. So we want something in minutes and we want something in seconds. Sorry, this is minutes, this is an N, and something in seconds. So first of all, you use your calculator, you do 50 divided by 3, and you get the decimal format. So the decimal is 16.666. We only take the 16 for the minutes, and then we subtract 50 over 3 minus 16. So 50 over 3 minus 16 will give us 2 over 3. And then this is the remaining amount, which we need to convert to seconds. So 2 over 3 times 60, again, gives us 40. And we put the 40 here. So either you use long division or you use the calculator as I showed. And either way, you should get 16 minutes and 40 seconds. And this is the correct answer according to the marking scheme. So we seem to be doing fairly okay so far. Let's move on to another problem. On the first part of a journey, Alan drove a distance of X and his car used 6 liters of fuel. The rate of fuel used by his car was 600 over X liters per 100 kilometers. Alan then drove another X plus 20 and his car used another 6 liters of fuel. Write down an expression in terms of X for the rate of fuel used by his car on this part of the journey. Give your answer in liters per 100 kilometers. So for a distance of X, so this is kind of like a ratio problem. For a distance of X, he used 600 over X. And since it's the same car, the rate of using fuel is actually the same. The car uses fuel at the same rate, always, regardless of the distance traveled or whatever. So because he used 6 liters of fuel in a distance of X, we said that the rate of fuel was 600 over X liters per 100 kilometers. Now, if he drove a distance of X plus 20, and his car used another liters. ماشي طب خلاص يبقى كده كده عك. يبقى احنا كده كده لازم نعمل edit. ماشي هو هنا يستخدم 600 على اكس 600 على اكس عشان مين؟ هنا 600 على اكس بلس 20. So in this problem, on the first, so this is a new problem here. On the first part of a journey, Alan drove a distance of X and his car used 6 liters of fuel. The rate of fuel used by his car was 600 over X liters per 100 kilometers. Alan then drove another X plus 20 and his car used another 6 liters of fuel. Write down an expression in terms of X for the rate of fuel used by his car on this part of the journey. So how do you figure out the rate of fuel used? It's basically the total amount of fuel used over the distance traveled. So in the first part, it should have been how much? It should have been 6 over X. This is the rate of fuel used per 1 kilometer, but they wanted to express it in terms of 100 kilometers. So the simple adjustment here is just to multiply the answer by 100, which is what they did. So this is the rate of fuel used for the first part of the journey per 100 kilometers. Now, he drove another distance, x plus 20, and the car used another 6 liters of fuel. So how would we express that? So it's basically 6 over x plus 20. And again, because they wanted in terms of 100 kilometers, so we just multiply our answer by 100. So we get 600 over x plus 20. So we get this expression here, and this is the final answer for AI. Let's check the marking scheme to make sure we are on the right track, and thankfully we are. This is the correct answer, 600 over x plus 20. So let's continue. On this part of the journey, let me write the answer to I in a smaller handwriting here, just to keep it for reference, 600 over x plus 20. On this part of the journey, the rate of fuel used by the car decreased by 1.5 liters per 100 kilometers. So what does that tell us? This tells us that the rate of fuel used initially was larger because now it decreased. And we want the difference between them because the difference is 1.5. So how do we set up an equation to represent that? So the difference, because we said here decreased by 1.5, so we want a difference of 1.5. So we just say 600 over x minus 600 over x plus 20 equals 1.5. Let's rewrite this as a single fraction in order to obtain a quadratic equation. Remember the same butterfly technique we used in the previous problem. 600 multiplied by x plus 20 minus 600 multiplied by x divided by the two denominators multiplied by each other. And this is all equal to 1.5. So how would we be able to solve this? One suggestion is to take the denominator and multiply it by the other side. So we obtain an expression similar to this, 600 times x plus 20 minus 600x equals 1.5 x times x plus 20. Next, we distribute to simplify. So we distribute the 600 here and there. We get 600x plus 12,000 minus 600x. This is equal to, and again we distribute here, 1.5 x power 2 plus 30x. I got 30x by multiplying 1.5x by 20. The nice thing about this is that we can simply cross out 600 with 600. I mean 600x with 600x, because these are equivalent terms in opposite signs, so you can just cancel out. And you can take the 12,000 to the other side. So you get 0 on the left equals 1.5 x power 2 plus 30x minus 12,000. But that's not exactly what they want. They want something with x power 2 without a coefficient, without a number next to it. So how would we go from our equation to this equation here? We simply divide everything by 1.5. So divide by 1.5 all around. Excuse me, there is a typo here. This is 12,000, not 2,000. So 12,000 divided by 1.5 as well. So the resulting equation becomes 0 equals x power 2 plus, so 30 divided 1.5. That gives us 20. So we write 20x minus, and 12,000 divided by 1.5 gives us 8,000. So we obtained the correct equation here, and we're done with double I. So for B, having obtained the equation, we are required now to solve the equation. So the most straightforward way of solving a quadratic equation is using the quadratic formula. There is another video that describes in detail how to do that, but I'm going to do it quickly here. So A equals 1, B equals 20, C equals negative 8,000. And the quadratic formula is minus B, so minus 20, plus minus root B squared, so 20 squared, minus 4AC. This is 1 and negative 8,000. And we divide all of this by 2A. So 2 times 1. Let's evaluate the stuff inside the bracket. So this becomes 400. And the negatives cancel out, so we get plus. And 4 times 8,000 gives us 32,000. So we want the square root of 32,400. And that's 180. So we get negative 20 plus minus 180 over 2. So we get two equations here. Either negative 20 minus 180, which is negative 200. You can use your calculator. Negative 20 minus 180 over 2, or negative 20 plus 180 over 2. This would give us negative 100, and this would give us 80. So the two answers are positive 80 or negative 100. Just to make sure that we are on the right track, let's check the marking scheme. And in fact, we are correct, thankfully. The two results here are negative 100 and positive 80. So in problem C, we are required to find the rate of fuel used by Alan's car for the complete journey. Of course, since we are back to a real-life problem, we have to take the positive value of x only. So we will only consider the 80. And we are required to find the rate of fuel used throughout the entire journey. So Alan first drove a distance of x, which is now 80. So 80 kilometers. And he used 6 liters of fuel. And then he drove x plus 20, so this would be 100 kilometers. And he used a further 6 liters of fuel. So the total fuel used would be 12. and the total distance traveled would be 180. But this would give us the rate per 1 kilometer. However, we want it per 100 kilometers. So we just multiply by 100 in the numerator, and we finally calculate 1,200 divided by 180, which gives us 6.67 liters per 100 kilometers. Let's check the marking scheme to make sure we are on the right track. Yes, thankfully, the correct answer is 6.67 right there. We will move on now to other word problems that don't necessarily have to do with distance and speed and time. So in this problem, we have a shop, and the price of a monthly magazine is $M. The price of a weekly magazine is M minus $0.75. One day, the shop receives $168 from selling monthly magazines, $207 from selling weekly magazines, and the total number of the magazines sold is 100. We want an equation in M. So first of all, this has to do with business. You should know that sales equals price multiplied by quantity. So the number of magazines I sold multiplied by the price of a single magazine gives me the sales revenue from these magazines. So let's apply this to the weekly and to the monthly. Let's call the quantity of weekly magazines Y, and let's call the quantity of monthly magazines X. So this is X and this is Y. So we have two equations in X and Y. We can say 168, which is the total revenue of monthly magazines, is equal to the price of a monthly magazine, which is M, multiplied by the quantity of a monthly magazine, which is X. And we can rewrite this equation because we don't really want X and Y. We want to get rid of X and Y because we only want M. So we isolate the X. So we can just rewrite this as X equals 168 over M. And then we repeat the same process for Y. We have 207 is equal to the price of a weekly magazine, which is M minus 0.75 multiplied by Y. So therefore, using the same logic, Y equals 207 divided by M minus 0.75. And we should also know that the total number of magazines is actually X plus Y. So X plus Y equals 100. And all we have to do is just substitute these values here, and we have an equation in M. So let's try to do that now. I'm going to start at the left here just to get some space. So we have 168 over M plus 207 over M minus 0.75 equals 100. Then we do the butterfly technique, multiply these together. So we get 168 multiplied by M minus 0.75. And then we multiply the M by the 207. And the sign here is plus. So plus 207M divided by M times M minus 0.75. And all of this gives us 100. So the easiest thing to do here is to take the denominator and put it next to 100 here. So we have 100M times M minus 0.75. And we no longer have a denominator to begin with at all. So now we have an equation that we need to sort of simplify in order to get a quadratic equation. So let me just clear some space at the top so that we can continue. So let's start by distributing the 168 over m and over 0.75. So we get 168 m minus 168 multiplied by 0.75. That gives us 126 plus 207 m. And this is equal to 100 m multiplied by m. So we're distributing also the 100 m over each element of the bracket here. So we get 100 m squared minus 100 times 0.75 is 75, so 75 m. This is the equation that we have. Next, we take the left-hand side and put it in the right-hand side. And we change the signs, of course. I'm going to start by writing the right-hand side first so that I get a positive m squared here. So 100 m squared minus 75 m. And then we start transferring the left-hand side to the right. And we change the sign of each, of course. So we have here minus 168 m plus 126 minus 207 m equals 0. Finally, we need to collect the like terms. I will start erasing part of the initial work just to give ourselves some space. So now we need to collect the like terms. We have 100 m squared. This is a unique term. We have negative 75 m. So let's first get rid of this 100 m squared. We already wrote it down. We have negative 75 m, negative 168 m, negative 207 m. So on the calculator, just write negative 75 minus 168 minus 207. That gives us negative 450 m plus 126. That's the remaining term here, equals 0. This is not quite like what they wanted because they wanted 50 m squared. So how would you get 50 m squared? How would you get here 50 m squared? Simple, you just divide by 2. Of course, you have to divide everything by 2. So dividing each term by 2, you get 50 m squared. 450 divided by 2 gives us 225 m. And 126 divided by 2 gives us 63 equals to 0. So we got the correct equation, thankfully, and we are done with question I. Next, we want to find the price of the monthly magazine. All we have to do is apply the quadratic formula minus B. So here A is 50. B is negative 225. C is 63. Minus B would be positive 225 plus minus root B squared would be 225 squared. I don't take the negative because I'm squaring anyway. For more details, you can check out the video on quadratic formula. Minus 4AC. So 4 times 50 times 63. This is all divided by 2 multiplied by 50. So this is the value of x that we're looking for, or the value of m to be more accurate. Next, we have to simplify. So 225 squared is 50,625 or 50,625 minus 4 times 50 times 63 would be 12,600. And then you calculate the difference. So you do 50,625 minus 12,600. This gives us a certain number. We just square root the answer. Excuse me. So you get 195 after taking the square root. So m equals 225 plus minus 195 over 100. So this gives us two possibilities. 225 plus 195, that gives us 420. So either it's 420 over 100, which is 4.2, or 225 minus 195, that gives us 30. So 30 over 100 is actually 0.3. So do we accept both answers? They're both positive, but are they both correct? Actually not, because this is correct, but this wouldn't work even though it's positive, because we have here m minus 0.75. So you have to think about that. If m is 0.3 here, you get a price that is negative, and that doesn't make any sense. So we have to reject the 0.3, and the final solution is $4.2. This is the value of m. So let's check the marking scheme. And thankfully, we have the correct answer here. So we are done. So this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.